Hi guys, welcome to my video. So today I'm going to discuss about the catalytic cycle for cytochrome-C-oxidase. So before going to this cycle, I would just like to revise the basic function of cytochrome-C-oxidase. So cytochrome-C-oxidase is involved in the oxidation of food. For example, glucose plus oxygen is converted into carbon dioxide plus water, and in this process energy is released. So cytochrome-C-oxidase is basically there is oxygen being converted to water in that reaction. So that work is done by, or that reaction is catalyzed by cytochrome-C-oxidase of turning the oxygen to water. So if cytochrome-C-oxidase is not functioning properly, then the glucose will not be converted to the glucose, so glucose will not be converted into energy, and our body will not get energy properly. So this function is of cytochrome-C-oxidase is very important. Now before going to the cycle, we should also have a basic idea about the structure of cytochrome-C-oxidase. In cytochrome-C-oxidase, the structure is a bit complex. There are 2 copper and 2 iron centers. 1 copper and 1 iron is involved in the transport of electron, and the other copper and iron are involved in the binding of the oxygen. So 1 copper and iron, they are having coordination sites fully occupied. So that is why they don't involve in the binding of oxygen. Copper has 4 coordination sites binded, and iron has its 6 coordination sites binded. So they will just be involved in the transport of electron, and there is another copper and iron. So there they are having the vacant coordination sites. Copper is having 1 coordination site vacant, and iron is also having 1 coordination site vacant. So those 2 will be involved in the binding of oxygen. So here there is the copper 1 and iron 2. So we add the oxygen in it, and what happens is oxygen is binding to our iron, and iron oxidation state is changing from +2 to +3. So now what is happening is here it will be converted into superoxide by receiving 1 electron from iron, the oxygen, and that O- will go and bind to this copper 1, and the oxidation state of copper will be changing to +2. So here we can see that there is a peroxide linkage between these oxygen, and this dotted line is just showing that these 2 are having some interactions, non-covalent interactions going on between them. So now what we are doing is we are adding 1 H plus here, and here what will happen is there will be heterolytic cleavage taking place. That means 1 oxygen will be getting negative charge and 1 will be positively charged. So here the bond has broken to this side, so this oxygen will get a negative charge, and this hydrogen H plus will come and bind here. So we will get copper in +2 and OH is attached to it. Whereas here what will happen is this will have a positive charge on the oxygen. So there will be a positive charge on this oxygen. So iron, there will be surrounding ligands to this iron center, like histidine is there and other ligands. So one of the ligand will give its 1 electron to this O plus, and this ligand will be converted into a radical and positive charge. So 1 electron on this oxygen, and iron will give another electron, and iron will go to from +3, it will go to, here it was +3 first, now it will go to +4, and this double bond will be formed. Now Fe is not going in the plus 5 oxidation state because it can only do so if it has a very electronegative ligand surrounding it. But here, like, there are no that electronegative ligands, like here nitrogen based ligands are there, so that's why it will be in plus 4 oxidation state. And here we can see that a radical intermediate is formed, and this is the final result that we get. Now we are adding one H plus and one electron. So H plus will take this electron and it will convert into a H radical. And here what will happen is, here we can see homolytic cleavage will take place. So one electron will go to iron and one electron is going to oxygen. So Fe will come in the plus 3 oxidation state. Oxygen will have one electron and this H radical we get from here, and that will form Fe plus 3 and OH attached to it. Now in the final step we are adding 2 H plus 2 electrons. Now what happens is we are adding 2 H plus, so one H plus will go and bind with this OH and one water molecule from there goes out and another H plus will go with this, so we will having 2 water molecules going out. So if these two are like leaving, and there will be 2 electrons given, so one electron will be taken by this and one electron will be taken by Fe3. So this taking one electron will go to copper 1 and this taking one electron will go to iron 2, and this OH will leave in the form of water. So this we got back our first step what initially we had took. So this is just in brief about the cycle. So thank you so much for watching my video. Please subscribe to my channel and like and share this video. Thank you.